Our goal is to sketch the graph of this parabola by transforming its equation into one that looks like an equation from the last section, 11.6, where we learned how to easily graph parabolas that look like this. And the process for doing this is called completing the square. And that description, completing the square, applies to a lot of different things in algebra. So this is a particular kind of completing the square. Keep a pretty close eye on the steps, because the steps are important to get straight. So take this number and move it sort of off to the right out of the way. And the idea is we're going to add something here, and then we're going to move over here and take it away so that the net effect on the right-hand side of this equal sign is nothing. We change the way it looks, but we don't change what it is. So, having said that, what completes the square here? Well, you always go to the coefficient of the x term, not the x squared term, the x term. You write it down, you cut it in half, and then you multiply whatever that is by itself. So 1 is the thing that will make this be a perfect square. And if we're adding 1 here, then we better come over here and subtract 1. So now, what does f of x actually look like? This is supposed to be a perfect square, so it's supposed to factor into something times itself, and sure enough it does. So now what do? Well, we have x plus 1 quantity squared minus 4, and now we're in this shape, where a is an understood 1, and so where's the vertex? The vertex has a y value of -4, and it has an x value of -1, because -1 for x is what makes the quantity in the parentheses 0. So where is that vertex? Well, it's at x equals -1. It's at y equals -4. This 1 says it's opening upwards and has kind of normal thickness. This is a good enough sketch. It tells me you know where the vertex is. It tells me you know it's opening upwards. And if you want a better graph, you could always put in some points, or you could do this on Desmos. So let's take a look at another one. This completing the square only really works when you have this number being a 1. And so we have some problems here. We really do. So let's take a look at what happens when this form of the equation is given to you. We're still going to move the plus 7 out of the way, but we're going to factor out a -1 in front. So let's see. First of all, does this equal what we started with? If we distribute the -1 through, we'll get a minus x squared, and we'll get a minus 2x, and this 7's not affected by the -1, so it's just a plus 7. So we're good to go. Now we're going to add something here, and whatever we add here, we're going to see what that does, and we're going to try to undo its effect over here, so that the net result is we still have something that equals this. Well, just like on the last problem, the way to figure out what goes here is to start with that coefficient, cut it in half, and multiply it by itself. And that'll give us 1. But be careful, careful, careful. When you put a plus 1 right here, this minus 1 is still getting multiplied by that. So the net effect is that this is -1, because this is a minus x squared, this is a minus 2x, and now this is a minus 1. And to undo that minus 1, we would have to do a plus 1. So now we get this. This is still x plus 1 times x plus 1, just like the last problem. And this is plus 8. So now we know. The y value of the vertex is 1, 2, 3, 4, 5, 6, 7, 8. The x value is -1, because that's what makes this 0. So there's the vertex. It's normal thickness opening downwards. And so our parabola will look like that. If you want a much, much, much better picture of the parabola, use Desmos. It's easy. It's simple. Let's do one more of those. So I'm going to factor a 2 out, because we need this trinomial to start with a 1x squared. I'm going to leave some room. The plus 23 just comes out here and is by itself. It's a good idea to check and make sure that what I've written here equals what's written here. Otherwise, we've changed the problem and bad things are going to happen. And they do, because this is 2x squared plus 16x and then plus the 23. So now we're going to complete the square here and make up for its effect here. To complete the square, you go to the 8, the coefficient of the x, and you take half of it, and then you multiply that half times itself. So the thing we need to add here is 16, but that does not add 16 to the right-hand side. It adds 32, because this 2 is affecting it. Take a look at what I've written right now. I've got the 2x squared, I've got the 16x, I've got the 23, but this one down here has a 32, a 2 times a 16. It's 32 too big, so let's take away 32. Now, this whole thing simply equals what I started with, and that's what I want. So I have a 2 times, and this is x plus 4 times x plus 4. It's a perfect square. And 23 take away 32 is negative 9. And so now can we sketch this parabola? Well, I think so. Where's the vertex? Well, the vertex has a y value of negative 9 and an x value of negative 4. So 1, 2, 3, 4. 2, 3, 4, 5, 6, 7, 8, 9. And this says it opens upwards and is a little tiny bit steeper than normal, whatever that means. And so this is the vertex, and we're feeling pretty good, right? It's just a sketch. It just proves that you kind of understand the idea of how to find the vertex and how to find the direction and kind of know where the parabola is. If you need an actual good graph of a parabola, then you're going to need to find points by putting in numbers for x and calculating the output, and then plotting those points. And you can see plenty of examples in the software of that, and you can see the actual answer on Desmos anytime you want.